Hello and welcome to today's video where we're going to talk about how to find the arc length of a circle. So arc length is the length around a portion of a circle, so it's kind of related to circumference because circumference is the length around the entire circle. Arc length is just a part of that. So, and it's different, a key here is that it's different from arc measure, which is the degree size of its central angle. So here arc measure would be 45 degrees, but we're looking for arc length. So it's a little bit different. That can be confusing sometimes, but just know that it's a little bit different. So arc measure is an angle, arc length is a length. So it's really intuitive because let's think if we had a circle here where we know its circumference was like 30 pi. So the length around the whole thing was 30 pi. And let's say we were just looking for the arc that takes up half the circle. So we're looking for that arc. Well, that must be 15 pi because we have 1/2 of that circle right there. And that's really exactly what we're doing with this. So we're kind of relating everything back to that circumference that we talked about earlier, which is the length around of an entire circle. Let me write out those formulas here. So circumference equals, 2 pi r, which also equals pi times d. D is diameter and r is radius. Okay, and so that's what we're doing here. We're taking the measurement of angle AB divided by 360, so that's the portion around the circle really. And then we're multiplying it by the length of the whole circle. And then so this is circumference, length around. So it's really intuitive, and hopefully, I really hope that you'd be able to kind of think of this if you were just given a practice problem. So I don't want you to feel like you really have to memorize the arc length formula. I hope you could kind of just like reason it out. That'd be good. So let's look at this example and just apply this. So we're looking for the length of AB, trying to find that distance between those two. And so I have AB, that arc measure or arc length must be the arc measure, which is 45 degrees. Divided by 360 times 2 pi r, 2 pi times 6 because we're given the radius this time. That's nice. So AB equals, I'm going to simplify this fraction, 45 divided by 90 is going to give me 1 divided by 8 times 12 pi, which is going to become 12 pi over 8. Then I can just simplify that fraction a little bit and I'll end up with 3 pi over 2. So that is the arc length here. So that means the measurement between A and B is 3 pi over 2. And the measurement around the whole circle would be 12 pi because that would be the circumference. So we're just taking a portion of that 12 pi here, and that's the measurement around that one part of the circle. So hopefully that makes sense. Now let's get into some more examples. So given that the area of a circle is 16 pi units and the measurement of the angle CD is 120 degrees, find the length of arc CD. Okay, so I want to know the length of this arc. I want to know this measurement right here. So I'm just going to write my arc length formula. So I know the CD is going to equal, it's going to equal that measurement. So 120 divided by 360 times the circumference. But do I know the circumference? So I know circumference is 2 pi r or pi d. So am I given the radius or the diameter? Unfortunately, I'm not. But I am given the area, so I need to use that to my advantage. So I know A equals pi r squared, and I know that that equals 16 pi in my example. So I can solve for r pretty easily. Just divide both sides by pi. That cancels. I'm left with r squared equals 16. So that means r is going to equal 4. So now that I have that, I can plug this back into my circumference formula, and I'll plug it into the 2 pi r example. So 2 times pi times 4 is going to be 8 pi. So I have my circumference here. So now I can plug this back in finally to this example, to our initial equation that we wanted to solve all along. So multiplied by the circumference is 8 pi. And that equals, I'm going to simplify the fraction in the front. 120 divided by 360 is 1/3 times 8 pi, which equals 8 pi divided by 3. And that will be the length around that arc. So 8 pi over 3 is my measure from C to D. And the measure around the entire circle is 8 pi. And this is it's kind of really easy here. If you just had the circumference, you could think, well, okay, we're 120 degrees. That's 1/3 of the length of the circle. So it's just going to be 8 pi divided by 3 because we have 1/3 of the pi. We have 1/3 of the circle here. So that's why it is 8 pi divided by 3 intuitively. Okay. So last example here. Given that the length of the arc FH is 5 pi and the diameter of the circle is 10, Find FH, measure of angle FH. So now we've actually started with a different thing. We've kind of been given the arc length, and we need to find the measurement. So we can, again, plug in our formula. So 5 pi equals, well, we know it's the measurement of FH divided by 360 times the circumference. And do I know the circumference? No, but I can find it out really easily, right? It's 2 pi r, which equals just pi times the diameter, which means that it's just going to be 10 pi. Because the diameter is just the length from end to end, and radius is half of that always. So that's why we got that is pi d. Okay, so now I just plug this back in here, and I get 5 pi equals measurement of FH divided by 360 times 10 pi, or not 8 pi, 10 pi, if I can write. So 10 pi here. Divide both sides by that 10 pi. And then now the pi's, as you know, are going to cancel, and I'll be left with 1/2 equals measure of angle FH over 360. Multiply both sides by that 360 to get FH by itself, and we'll get 180 equals the measure of angle FH. So now let's draw that in here. So if FH is 180 degrees, that means it must be a straight line, right? Because it's 180 and the whole circle's 360. So I have F here, I have H here. What I just figured out is that this measurement around here, well, what I knew actually is that it's 5 pi. But I also knew the circumference was 10 pi. So 10 pi is the whole length. So that means I have exactly half of it, right? Because I have 5 pi. And then also, I actually know the measurement of FH. This is really just making sure that we have all of our, we're really understanding what we're doing. Because this is a diameter, it's just going from end to end because it's a straight line. So this FH must be 10 as well because it is a diameter here. So hopefully that makes sense. I really hope that you're able to kind of get the intuition behind this. Hopefully you're able to figure out that the length is just the length, the arc length is just the portion around the circle multiplied by the circumference of the circle. It's an intuitive formula, and it really helps out when you're trying to do some more complex problems. It's good to just kind of reason out the formula a little bit. So thanks for watching, and don't hesitate to contact me with any questions. Have a good one.